Peer nodes. In the last section, I gave you an overview of the three different types of nodes: client node, peer node, and the orderer node. Focus of this lecture is the peer node. In this lecture, you'll also learn about two special types of peer nodes: the anchor peers and the endorsing peers. Members in the blockchain network need to set up peers in their infrastructure for participating in the network. Here, for example, member A has set up 3 peer nodes. All of these peers need to be configured with the appropriate cryptographic material such as certificates and other information. Peers in the members organization receive transaction invocation requests from the clients within the organization. As transactions are created in the network and new blocks get generated, these blocks are sent out to the peers by the ordering service. And peers receiving these blocks need to validate and update the ledger managed on the peer node. Inherently, this kind of an architectural approach is highly scalable, as there is no need for a centralized effort to scale the network or to scale the infrastructure. Each member organization can look at their needs and set up the infrastructure based on their requirements. So for example, the member organization A has 3 peers, whereas B has decided to set up only 2 peers because that may be enough for their requirements. Member organization can have multiple peers, but not all peers receive the block information from the orderer. Only the anchor peer receives the blocks. Here in this diagram, the anchor peer is this one. So what happens is when the anchor peer receives the block, it updates the other peers in the member organization. To avoid single point of failure, an organization can create a cluster of anchor peers or more than one anchor peer. Anchor peers are set up and defined as part of the channel configuration. And the anchor peers are by default discoverable. Now what that means is that any peer that is marked as anchor peer is discoverable by the orderer and other anchor peers. Let's talk about the endorser role. Peers may be marked as the endorser, or they can take up the role of endorser, in which case they're also known as the endorsing peer. Client sends the invocation request to the endorsing peer. On receiving the request for the invocation, the endorsing peer validates the transaction. For example, it checks if the end user has used a valid certificate or not. If the validation checks out fine, then it simulates the chain code. What that means is that the endorsing peer executes the chain code. Now, after the execution, it does not save the state of the chain code back to the blockchain, as it is simply simulating the chain code. And you will understand much better how this process works as part of the transaction flow. So for the time being, just think of simulation as execution, but the data that has changed in the chain code is not saved to the ledger at this point. At the end of the endorsement process, the endorser either rejects the transaction, and this may happen due to multiple reasons. For example, the security aspects didn't check out, or the execution failed, or the endorser may respond back with an endorsed transaction request. More on this later. The primary objective of the endorsing peer or the endorser is to protect the network. Now, when I say protect the network, it doesn't necessarily mean protect from intentional attack on the network, but it also means that it needs to protect the network from a misbehaving or a misconfigured node on the network. And since every member organization is responsible for configuring their own nodes, which is peers, there is a possibility that a misconfigured node may be unintentionally added to the network. Another advantage of this mechanism is that only the endorser needs to execute the chain code, and this will improve the overall scalability of the infrastructure, since there is no need for all nodes to execute the chain code. The focus of this lecture was on the peer nodes. Every member organization needs to set up peers in the organization. Peers receive blocks from the network. There is a special kind of peer that is set up to receive the blocks, and that peer is known as the anchor peer. Anchor peer receives the blocks and then provide these blocks to the other peers in the organization. Then there is endorser peer or the endorsing peer. The endorsing peer receives the transaction request from the client. On receiving the transaction request from the client, it simulates the transaction. That is, the transaction is executed, the chain code is executed, but the state of the chain code is not updated in the ledger. The endorser then rejects or accepts the transaction after it has carried out multiple validation checks. The primary objective of this endorsement mechanism is to protect the network from intentional as well as unintentional attacks.